Do you want to learn about E and Z? Do you want to learn about cis and trans? Because we're going to talk about it in this video right now. Check this out. If you're watching this video, most likely you were in the SI session on Wednesday night and you got to witness the drama, the controversy that was the E and Z cis and trans distinction. We were talking about what it meant, and we got into some pretty technical stuff. At the end of the conversation, I said, by the way, a lot of chemists do blank. There's a possibility that Dr. Lane is one of those chemists. I'll get back to you. Turns out, she is. So, we're going to go over what E and Z and cis and trans means in this class. You can pick one, and what I recommend you do is to either become an E and Z person or a cis and trans person for the rest of the semester. All that trickery in Orgo 1 that was designed to exploit whether or not you knew the difference between E and Z and cis and trans doesn't really come up in Orgo 2 as much. It's crucial to know the difference, for sure. But when it comes to naming molecules, you can pick E and Z, cis and trans, you'll be right on the exam either way. We're going to talk about E and Z first. It's basically Orgo 1 review. So if you already know what this is, skip to the timestamp that I write in the description to go to the cis and trans explanation. So check it out. What is E and Z? Look at this. We got a alkene on the board. It's pretty cool. We have a bromine here. We got kind of like an ethyl group here, a methyl group. We got another methyl group. So when you're ranking things by E and Z, we're going to first split the alkene in half, right, with our mind's eye. Kind of like this. And then what we want to do is we want to rank each of these right here. And we rank them exactly the same way as we do RNS, which is by atomic number. So, we got a bromine, and then we got a carbon. Which one of these has the higher atomic number? Bromine does. We're going to put a little star right here to notice that this has the higher priority, aka the higher atomic number. Now let's go to the other side. We got a carbon here. We also have a carbon here. That's a problem. Now we're going to talk about what Dr. Lane likes to do when you have this tie between each branch, right? You might have seen her do this on the day that she was teaching, I think it was ether naming. She does what I like to call the squiggly line technique. Look at this. You're going to draw a squiggly line from the carbon that we want to look at. And then we write C. That C is talking about the carbon that we're going to go ahead and study real quick. We open the parentheses, and then inside the parentheses, we write the three atoms that that carbon is bonded to, ignoring the bond, going to either the alkene double bond or the chiral center if we were doing RNS. But in this situation, since we're doing an alkene, we ignore that bond right there, since it's going to the double bond. So what three things is this carbon bonded to that are not this, basically? So cover that up. And when we write them in the parentheses, we write them in descending order of atomic number. You'll see what I mean in a second. So we got this carbon's bonded to a carbon. Okay, now we come back. It's also bonded to two hydrogens. So we got a carbon, a hydrogen, and we write those three things inside the parentheses in descending atomic number order. So it's going to look like CHH. We do the same thing for this carbon right here. Again, this carbon is referring to this right here, and inside we write the three atoms that that carbon is bonded to while ignoring the bond going to the alkene, or the chiral center if we were doing RNS, but we're not, so check it out. This carbon is bonded to 3 hydrogens, so we're just going to go ahead and write HHH. So, now that we did that, we look inside the parentheses, and at the first point of difference between these letters, whichever one has the higher atomic number at the first point of difference gets the priority. This is a pretty easy example because right off the bat, the first atom, we got a C and an H. A C has a higher atomic number than H, so this branch gets the priority. So now we're done. Check it out. In the E and Z system, both of these priority branches are on the same side of the alkene. This is going to be called Z. You can remember this pretty easy if you remember this saying. It goes like this. The same side. You kind of become French for a second. I think that's a French accent. Either way, sounds kind of cool. So it's a good way to remember Z for the same side. All this is Oracle 1 review. And obviously the opposite of this would be E. We're going to now talk about what cis and trans means with this same example. And I want to note a key distinction. The example that I drew on the board is a perfect example of when Z and E does not equal cis and trans. When we go ahead and do the cis and trans version of this, it is not going to be on the same side. And I'll show you why. Alright, so in SI, we talked about, oh my god, you have to have the same groups on either side, and cis and trans sometimes doesn't always work. Throw that out of your mind. It's going to get way more chill in Orgo 2 with Dr. Lane because of this clear distinction right here. Look at the longest carbon chain, step 1, right? Is it floppy or not? If it's floppy, it's trans. If it's on the same side, it's cis. You're done. So let's take a look at the longest carbon chain on this one and go ahead and call it a day. Here we got the longest carbon chain, right? Does everybody agree? 1, 2, 3, 4, 5. 1, 2, 3, 4. That side wins. Is it floppy or not? It's on the opposite side, right? Trans. Checkmate. You're done. So check it out though. In the E and Z system, this side and this side had priority. They were on the same side and it was Z. In this way more chill, in my opinion, way to do things, this is on the opposite side and now it's trans. So there's a couple people that got traumatized in Orgo 1 with when is E and Z not the same as cis and trans. Hopefully this cleared it up. Again, pick one, whatever you like best. Both are equally correct on exams, but as long as you do this the rest of the semester, you're going to dominate. All right, good luck and Godspeed.